it says it's not recording. Okay, it's working. So here's the mean, 38.72, and the standard deviation is 3.17. And again, we are asked, find the probability for the proportion of 3-year-old females who have a height less than 35. If this is 38, I'm going to say that this is 35, and they want us to determine this area. This area is the same with the probability or the proportion from all the study, all the females in the study that have a height less than 35. We will enter it as negative infinity to 35 with the mean and the standard deviation. And we'll find the area, which is the probability. So P for X to be less than, but it's continuous. Where I put the equals symbol or no equal symbol, it's still the same thing. 35. So I'll go to normal PDF. Go back to distributions. Normal CDF, not PDF, sorry. I misspoke. Normal CDF always. This time, it's from the leftmost point. So I need to use negative symbol, this negative symbol, and then second and the comma, and 99. I'm telling the calculator, make sure you start from negative infinity. And the upper will be 35. And of course, the mean will be 38.72. And of course, the standard deviation 3.17. And the calculator will compute that area for us. Just press enter. And the area is 0.1203. What will be the interpretation? It means that 12% from the study, from all the females in the study, had a height less than 35. And if I randomly select one, her chances of having a height less than 35 are 12%. Any questions? Part B. Use the normal model to determine the probability that the randomly selected 3-year-old female is between 35 and 40 inches. Okay, we're going to go back to these problems with Stat Crunch in a minute. So this time, they want between 35 and 40. So I'm going to say, I don't know exactly, I don't have units here, I'm just explaining what we're doing. So if this is 40, then this time we are asked to determine this area between 35 and 40. So then the probability for X to be between 35 and 40. Again, I don't have to put the equal symbol at all because it's 0 at 35 and it will be 0 at 40 alone. Okay, so go back to second and distribution, still normal CDF, but now the lower is 35, the upper is 40, and I already have the information as the mean and the standard deviation, and now I'm going to paste and press enter. So I get 0.5365 or 53.65%. Again, two interpretations. From all females in the study, it was found that 53.65% of them have between 35 and 40 inches in height. And if I randomly select one from the study, her chances of having the height between 35 and 40 is roughly 54%. Any questions? Yes, please.
Quick question. So it's just the number minus the 40, and that's pretty much it of like how you get the decimal?
Oh no. Very good question. Normally, the mathematical by hand, which is cumbersome, if not impossible, which it's not part of this course, is the integral from 35 to 40 from this function, dx. But we don't know how to find integrals in this class. The calculator is doing this for us. So this is the area. that is 0.5365. We cannot calculate this by hand. The calculator is giving it to us, is calculating it for us.
It's calculating that part of the line between 35 and 40 is what you're saying?
No. Very good question. Very good question. It's this one, this area was so simple to calculate because the function is just a rectangle. I don't have anything. But for such a function, we are not capable of finding the area under the curve. It's what I shaded in. All this, because remember, everything is 1. Everything that you see under the curve between the x-axis and the curve is 1. This area is 0.5365.
Yeah, that part makes sense. I think I just got confused when you were talking about the green box on the right there.
We don't know this. This is not for us.
Right.
This is for calculus.
All right, deal.
No. I was just trying to explain that we cannot do this by hand in this class. We have to use the normal distribution. And we are using the normal CDF, which gives us the area between the x-axis and the graph and these two vertical lines. This piece right here, this is 0.5365. This piece is 0.1203, and I can find this for you in a blink. How do I find this? Very simple. 1 minus 0.1203 minus 0.5365, and I found that area. This area must be 0.3432. Mandatory. Because this function, if the area under this graph is not 1, has nothing to do with probabilities. Okay? So you don't even have to look at this. We don't know how to calculate integrals in this class. So this, because I have this piece and I have this piece already, I could determine this by subtracting from 1 this and this. And if they don't add up to 1, then this is not a probability distribution, density function. Is this better, everyone?
Yeah, I think so.
Yep, thank you.
Please stop me, because only if you stop me I know whether I said something or I didn't. Maybe I didn't. And I have to say it again. Part C, find the height of a 3-year-old female at the 20th percentile. Uh-oh, what does that mean? This is the 50%, right? 1, 2, 3, 4, 5. So 0, 10, 20, 30, and 40. And then 60, 70, 80, 90, 100, pretty much. So they want us to determine the 20th percentile, which means this point, which means this area must be 0.2. So if this area is 0.2, where the 20th percentile is, which I don't have yet, I know that the mean, where is my mean? 38.72 is right here. And I know that this area is 20%, but I don't know this point. How much is x there? I don't know. So again, what does the 20th percentile mean? P20, or the 20th percentile. It means that from the entire study, 20% of the females in the study will have a height lower than this number that we will determine in a minute, and 80% will have a height higher. They will be taller than this number, which we do not have yet. For this to be determined, we have to use a feature from the calculator that is called inv norm. the inverse of norm, meaning I'm not given this to find the area. I'm given the area to find this. So the feature in the calculator, once again, is with inverse distributions. And go to number 3, inv norm. For the inv norm, we have to enter the area to the left, always area. In some calculators, area to the left. Here, as you see, these sophisticated calculators, they have other options. But area to the left, which is 0.2. Of course, the mean again, and the standard deviation, which was 3.17. That's the syntax for inv norm. So the area is 0.2. The mean is 38.75. And the standard deviation is 3.17. And yes, it's the left, and I paste. Again, so this is, did I put the commas that I needed? Yes, I put all the commas and left. Okay, so X is 36.05. Tell me what you got with your calculators. Before we look at another problem, we can always go back and check. How do I check? Very simple. I go to stat in distributions with normal CDF. The leftmost point is negative infinity. The rightmost point is 36.05. The mean, oops. No, I didn't mean that. 36.72. The upper is 36.05. Okay, so the mean is 38.72, and the standard deviation 3.17, and we'll calculate, and it has to give me 0.2. And it is not giving me 0.2. So I have a problem with the syntax then of the normal CDF. So yes, 36.05. The mean, yeah. Okay, I got it. I typed something. So the lower is negative 3.17. I have to get 0.2. If I don't, something is wrong. Yes, 0.1998. So I calculated also the probability that X is less than or equal to 36.05, and I'm not going to get exactly, it's 0.1998, the closest to 2 that I could find. Let's say we want to determine the 70, give me another percentile that you want to determine. So to calculate, give me another percentile. Anything. 80. You want 80? So 50, sure. 60, 70, 80. So this would be 80%. I don't have this, but I know that all this area has to be 0.8. So I repeat with inv norm. Area to the left, 0.8. Mean, 38.72. Standard deviation, 3.17. Left, yes. I'm not used to this left thing. This is new in these new calculators. Okay, so we got 41.39. So this number is X equals 41.39. You can always immediately check if you want to. So go to normal CDF. Lower is negative infinity. Upper 41.39. There is no need. It has to work perfectly. But let's convince ourselves, and then 3.17. And the answer has to be 0.8 or very close to 0.8. And it is 0.800. So the probability that x is less than or equal to 41.39 is indeed 0.8 as discussed. Any questions? Any questions? Okay, moving on. Example 4. Oh, the usual SAT question. The scores earned on the mathematics portion of SAT, a college entrance exam, are approximately normally distributed. Fine. So X approximately normally distributed with mean 516 and standard deviation 116. Fine. What scores separate the middle 90% of the test takers from the bottom and top? In other words, find the 5th and the 95th percentile. Very clear. So here's our mean of 516. And we really want to determine the middle 90% they want. If you want 45, 45, but obviously this piece and this piece must be equal. So from 100%, if I subtract 90%, I have 10%. So this must be 5% and this must be 5%. Because the entire area is 100% or 1. So we are asked to determine this and we're asked to determine this and say, look, from everyone who takes this SAT test, 90% of them have a score between blah and blah. That's what we are trying to determine. So we could use inv norm for this value here, and inv norm for this value here with the area to the left. I think these new calculators give the area to the right as well, but I haven't tested it, so you can try it if you'd like. So inv norm, area to the left, 0.05. Please do not put percentages in the area. The mean, 516. Standard deviation, 116. And my calculator's left. As I said, I have not tested that so far. So, yes, it's left. I want 325.19. So, 325. In order to determine this, I'm going to have the area 0.95 because I have 90% plus 5%. So it's 95% to the left. So go to second and inv norm. Area to the left, 0.95. And I have the rest, 516, 325. I'm sorry, 516 and of course 116. Yes, I have them still. And I get 707. So now I can say, from the information I have, I will conclude that 90% of the SAT takers have a score on the mathematical part, on the math part, between 335 and 707. What else can I say? Is that 5% have a score of higher than 707. 5% have a score lower than 325. But the chunk of them, the 90% between 325 and 707. Any questions on this? Any questions? Are we okay so far? Okay.
Yep.
Okay, last thing, and then we look at Stat Crunch. So last thing here before we, and we have a little portion of Chapter 7 left over for Wednesday. This is a very important notation. Z sub alpha. Z sub alpha. Obviously, when we talk about Z, we know it's normally distributed with 0 and 1. So every time we're asked to determine, and I have an example here, and we can make up any other example, we know that this is Z, we know that this is 0, we know that standard deviation is 1, and we want to determine Z 0.10. What does Z 0.10 represent? If this is 0, 0.1 will be somewhere here, which means we really want to determine this. So this is not inv norm, this is just a normal distribution. So we go to normal CDF from negative infinity to 0.1 with a mean of 0 and standard deviation of 1 because we are talking about the z-scores. So the upper is 0.1, 0 and 1, yes, yes, yes. It better be more than 50%, and it is. So the area is, so the probability for z to be less than 0.1 is 0.5398. It has to be more than 50% because here is 50%. So the area is 0.5398, or if you want, 53.98%. We are going to use this later when we get to inferential statistics. Okay, now allow me to share, unless you have questions,